Welcome to the Tesla Economist. Please hit the thumbs up and remember to subscribe. You can follow me on Twitter and talk to me on Patreon. Okay, I think I may have just found myself guilty of confirmation bias. For any long-time listeners, it's plainly obvious that I'm very excited about Tesla's 4680 batteries coming out. Finally, a Tesla that will have Tesla batteries. We know they're coming out soon, and then we have a new Tesla listed with EPA to only further validate a potential new Tesla being released. My excitement got the better of me, but that is not objective, and this is investing. This is why some people still invest in GM. So in this video, I'm going to be 100% objective and take my blinders off and try and analyze exactly what is going on with Tesla's new models and see if we truly can work out what battery is in this new Tesla Model Y all-wheel drive with 279 miles of range, whether it's LFP, 4680 or 2170. Let's find out. So we have these EPA numbers for the vehicle, which is how this all began. A 279 mile Model Y all-wheel drive. The EPA offers more information than just range. The one that is often used for efficiency is MPG equivalent. FYI, if you didn't know, MPGe is calculated by using 33.7 kilowatt hours of electricity equal to 1 gallon of gas. Now this new Model Y has an MPGe of 123. If we compare this to the Model Y LR, then it's about identical at 122 mpge. This is pretty close, very similar indeed. The long range uses 2170 batteries, so I could understand how anyone could quickly jump to the conclusion that it's a 2170 battery. And if it was 4680, then this would be disappointing, as we have much higher hopes for improved efficiency. The other metric EPA give us is kilowatt hours per 100 miles. These two are identical for the long range and this new model, both at 28 kilowatt hours per 100 miles. Okay, again, looking likely to be 2170 going by this. This does also give us some indication of battery size. If we multiply the kilowatt hours per 100 miles by the given range, then we get 92.4 kilowatt hours for the long range and 78.1 kilowatt hours for this new vehicle. Now the Model Y likely has around 82 kilowatt hour battery. I believe the figure that the EPA give us is the amount of energy it takes to charge the car rather than the actual capacity of the battery, and includes inefficiencies of charging. Therefore, going by this, the battery size of this new vehicle is probably around 69 kilowatt hours. That suddenly sounds like the kind of battery size that Tesla might use. Now a 69 kilowatt hour LFP battery to get that much range with an all-wheel drive crossover, well, that doesn't sound likely. But I want to humour the possibility. Therefore, the only way this could be achieved would be through improved battery energy density and new manufacturing techniques. Therefore, for it to be LFP, it must be produced at Texas. Now, just to get an extra perspective that if this was LFP and produced in the current manufacturing techniques, then we could compare the difference in efficiency between the Model 3 standard range or rear-wheel drive, between when it was using 2170 batteries and when it moved over to LFP batteries. The 2170 version was 142 mpge. The LFP version went down to 132 mpg, a difference of 10. Therefore, we might expect a difference of 10 mpge moving down to LFP, which would mean a Model Y LFP would be around 112 mpge. This doesn't fit in with our theory of it being LFP either, and again does point to 2170 batteries. Alright, well how could LFP achieve these efficiencies then? We need to reduce the weight of the car and improve the battery density. Therefore, we need to assume this is a new revolutionary new LFP battery. Possibly Tesla have been working with CATL. Surely there is some potential from Tesla engineers and experience that they could pool resources and improve efficiency of the batteries. There are rumours that Goshen High-Tech have partnered with Tesla to supply 200 gigawatt hours of LFP batteries for US production, and maybe they're supplying Texas with more efficient LFP batteries. However, this isn't meant to start until next year, so I think we can rule that out. BYD have denied rumours in the past of working with Tesla. The BYD Blade battery at its current state would not match up to the necessary efficiencies. As for battery chemistry improvements for efficiency, well, there likely aren't the same potential benefits to be gained from the iron cathode as there was with the nickel-based cathode, but possibly the anode. Now on battery day, we saw that adding silicon into the anode allowed a range improvement of 20%. This allows a greater number of ions to be stored in the anode, but I would guess that the iron cathode may not be able to use an equal amount due to the different energy density. Then at a guess, I would reduce this potential to just 10% for an LFP battery. The other improvements were cell design, but that is going to be a huge step. We surely would have heard something about a new design, unless Tesla have been working on this with CATL since battery day, as it would have taken a long time. Also, there is a new CATL fab being built next door to Giga Shanghai. The drone YouTuber Wuwa thinks this is a research lab, which perhaps Tesla and CATL will work on together in making a new, revolutionary new LFP battery. I wasn't expecting a big jump in energy density for LFP batteries for some time. Then, of course, we have cell-to-vehicle integration, aka the structural battery pack with front and rear die-casts, which increased range 14%, except I believe Tesla's LFP battery packs are already structural and they are already using the rear die-cast. So I think the only benefit for the new Model Y here would perhaps be the front die-cast, which wouldn't make a significant increase in range alone. Let's calculate then how much range a Model Y with LFP batteries might actually be capable of. Alright, if we start with the LFP Model Y from Shanghai, which has 525 kilometers of range NEDC, which when converted is around 221 miles EPA, this battery is a 60 kilowatt-hour LFP battery, and we now have an extra 9 kilowatt-hour battery, which is 15% larger. I would guess this might give us around 12% more range, as we have to compensate for the additional battery weight, which takes us to 254 miles of range. Then, when we add the additional 10% improvement in chemistry, then that would give us an additional 25 miles. Oh, wow, that comes to exactly 279 miles. Therefore, we've hit the LFP battery to reach this range. Have we missed anything? Were we comparing apples with apples? No, not entirely. Right, the Chinese Model Y, well, that's rear-wheel drive, and we have clearly been told this new Model Y is indeed all-wheel drive. When Tesla used to offer a rear-wheel drive and an all-wheel drive long range, the rear-wheel drive would get 15 more miles of range. Right, the additional motor, powertrain, and dispersed power between two motors means that you lose about 15 miles of range. This would then take the range that an all-wheel drive Model Y with a 69 kilowatt-hour LFP battery could get to would be only about 264 miles, unless the chemistry improvements were that much better. Bear in mind, we also would have thought we might have heard something about a new LFP battery chemistry being made, and how impressive it was. So this is what it would take to hit that range, an even more vastly improved chemistry that we've already mentioned. And if there's a battery company that has reached this level of efficiency with LFP, then I'm going to invest in that company too, because it's a big deal. In addition to that, I also managed to locate the certification summary information report for this vehicle filed to the EPA, which gives us a bit more information. It also shows the weight of the vehicle. Oh, now that is going to be interesting, as we can assume that the weight of the LFP batteries are going to be heavier. So let's see what we can compare. The curb weight shows this new model as 4,356 pounds. This makes it lighter than the long range and performance version, but only by 25 pounds. For what would potentially be 13 kilowatt-hour fewer batteries, we would expect a bigger weight saving. At 200 watts a kilogram energy density for 2170, it would be around 65 kilograms, or 143 pounds we would expect it to be lighter by. When we compare the difference in weight between the LFP Model 3 and the Model 3 long range, the LFP version is 172 pounds lighter, implying if the battery pack was around 69 kilowatt hours, then this would fit in with these weights. However, we are also comparing the weight of a rear-wheel drive against an all-wheel drive, which will obviously be heavier. In fact, if we compare Tesla's weight of their rear-wheel drive versus all-wheel drive long-range Model 3s, when Tesla used to offer both versions, well, there's an addition of 267 pounds. Wow, that is quite a bit of additional weight. Therefore, the LFP version of the Model 3 would actually be heavier than the long range if they were both all-wheel drive. Then why is there only a minor difference in weight between the new all-wheel drive Model Y and the long range? Good question, but possibly Tesla trying to get costs down for this other vehicle and using lower cost components, perhaps a lower cost motor that weighs more. We're only talking about a discrepancy of 100 pounds weight, which may even just be accounted for in larger wheels. But we are also talking about all these extra advances in production that might have reduced the weight. Well, if you recall, that really only applied to 4680 batteries, so I'm not sure an LFP Model Y could get down to this weight with that much range. Also, the standard range Model Y in China is 4,253 pounds, and that's rear-wheel drive. Now, if we have an additional 9 kilowatt hours of batteries, and if LFP batteries are 150 watts per kilogram, that would be an additional 60 kilograms or 132 pounds. Then we have the additional weight of the all-wheel drive system at around 267 pounds. That would take the total weight of an LFP Model Y with a 69 kilowatt hour battery to an estimated 4,652 pounds. Yet apparently the weight of this new model is only 4,356 pounds, a difference of 296 pounds. I don't think LFP manufacturing advances could have removed nearly another 300 pounds. This does, however, fit in about perfectly with 2170 batteries. We also get to see how much car this power is generating too, from the full EPA information report. The front motor power is 91 kilowatts, the rear motor power is 200 kilowatts, total power being 291 kilowatts. Now, for those Americans out there, that's 390 horsepower. That is a lot of power for an LFP battery. This does make it even more unbelievable. For comparison, a BYD Han with a 77 kilowatt-hour battery gets just 218 horsepower. Also, according to this EPA report, the long range has the same power as this new model. Increasing power reduces range, therefore I would have thought that an LFP version would have a lot less power. This is also noticeable with acceleration, as a long range is still a very quick car. This could mean that this new Model Y all-wheel drive will have a quick acceleration time also. I found the same information on the Model Y Performance, and it has front motor power 133 kilowatts and rear motor power 179 kilowatts, or total 312 kilowatts, which is around 420 horsepower, which does check out. If Tesla or whomever is supplying or making these batteries have managed to reach equal ranges with LFP batteries to where we are with nickel batteries, then this changes the industry. LFP batteries are probably about half the cost to produce than nickel. On top of that, they seem to be able to be ramped up in production a lot easier and faster, and are a lot more abundant. There are a lot of other benefits using iron over nickel, such as a safer, more durable battery too. I think there is absolutely no possibility that an LFP battery could derive close to that much power. It's simply not possible. This is probably the biggest giveaway. The weight is also far too light to be LFP. The battery day advances were mainly for 4680 batteries. Tesla's LFP vehicle doesn't stand to benefit from as much. I do expect Tesla to launch an LFP Model Y with this much range, but I didn't expect it for another couple of years. I think and hope we rule out the 4680 batteries though, as if this is the energy density we're getting from them, and the new manufacturing processes, I think it would be disappointing and doesn't really add up. As you know, my calculations had the 4680 under 50 kilowatt hour batteries, which is a big difference from 69, unless that maybe Tesla have locked this range with software with 4680s and you can upgrade it later, but I think that would be a waste of batteries that could elsewhere be used in other vehicles. Therefore, all things are pointing to this being a 2170 version, which is probably the last we expected. But don't worry, I thought this through, and it does make sense, and I look forward to going through what this would mean for the company. In reality, this could actually be what is most profitable for Tesla. Thanks for listening. Please hit the thumbs up and subscribe. You can follow me on Twitter and talk to me on Patreon.